Caleb, good to see you again, man.
Hey, morning, Russ. How's everything going today?
That's good. It's good. Hopefully we're going to get the tour of a lifetime here at Wilwood today.
Yeah, we're going to go and check out the building, see how the process starts from getting a vehicle into Wilwood, how our engineers design, develop, figure out what systems to put on the cars, and then the full process from raw material to manufacturing, powder coating, assembly, anodize, and getting that product out the door, and where we also do the installs and videos and everything. So
very cool.
Get a good full checkout today.
All right, cool. Can we kind of get started here? I see some stuff I'm already
so let's head on in. Everything that you see on the ground that is checkerboard is only for R&D purposes.
Okay.
So nothing manufacturing is going to be done. So what we'll do is we'll have a vehicle roll in here. We'll have our engineers come over with either our 3D scanner or our digitizer.
Okay.
We'll be able to knock up and get all the dimensions and basically a full 3D model of either the rear end and suspension or the front end and all the geometry that we need there for its upper and lower control arms, ball joints, pickups, all the data points that are very important to designing a brake kit properly.
Oh, cool.
Here's we'll go and design up the brake kits and the components, and then the bracketry and the individual items will head over to our machine shop over here, which again, these guys are going to only do stuff for whether it's the tooling itself that we use for the machining and the calipers,
right,
or it's going to be the individual brackets and those items. These are going to be all special projects and everything like that right now that Wilwood is currently working on, whether it's for our OEM side of the business, military, industrial, or it's going to be for the street performance racing category that we work with as well. Typically, we do certain other applications that go on Ford vehicles. We do a lot of military applications, so the Hummers and Humvees for the past like 30 years have all been Wilwood systems from top to bottom. Some of the rides that you see at amusement parks out there, we'll go and have our brake systems in them. The logging and mining industries need calipers to be able to stop the loads that they're carrying. Yeah, a lot of different industries that you don't expect to see products used in.
Yeah, because that's really all you think about. You don't think about a ride at an amusement park or even the military. You would think whatever the manufacturer, whether it be like you said a Hummer or anything else that the government uses, you would think it would have a...
You don't think that a windmill needs a brake caliper in the top of it to hold it static when it's not in motion.
Yeah.
There's a lot of different industries out there where you can see the applications of brake dynamics put into effect. And that's one of the reasons where Wilwood is Wilwood Engineering, not just Wilwood Disc Brakes, because we take our engineering and brake knowledge from all the different industries that we're involved in, and we can apply that to street performance, racing, hot rods, modern muscle, drag, and all the different applications that we go through.
Anything that needs to slow down?
Anything that you need to either hold static or slow down. We're pretty much there to be able to get you started.
All right.
Head on over to manufacturing real quick. This is going to be the main shop where all of it is done, all the magic has happened at Wilwood.
Okay.
All raw goods that are received into Wilwood for the forgings through our houses or our castings for our rotors, it will come through in our QA department, get checked through. And this is going to be in the main machine shop. So this is where all our CNCs are. With the amount of forgings and aluminum that we're going through, we normally have about 20 to 30 tons of aluminum shavings every month that we go through and just recycle alone. Like I was saying before, a majority of calipers that Wilwood offers are going to be a net forge. So we take the billet and smash it into the shape that's needed. So this is going to be the net forging that we start off with for our XRZ race caliper.
Okay.
And then we will go and machine down all the surfaces to be able to get you exactly where you need on your piston diameters, rotor thicknesses, pad options. So you can feel right here the difference in weight that we start off with, or that we end with, and where we start with for just one caliper body head.
Wow. Yeah, so there's plenty there to work with.
Plenty of material to be able to hog out and get you to your shape. And that's one of the reasons why again, with forgings, you have to increase and do a larger volume to be able to make it a cost-effective option. And that's one of the reasons why Wilwood, when we're doing our systems, like with our Dynalite calipers, which we'll see a little bit later as a finished option, those are something that one machinist can do about 500 calipers in one 8-hour shift.
Wow.
That we do. So we're doing thousands of those calipers a week and per month. And you can see
the comparison to
the raw that we start off with from the body. So again, these varying thicknesses all allow us to change the piston bore diameters, the rotor thicknesses, the mount locations that we're all going to be working with.
Yeah, usually with the Dynalite though, won't they use a thinner rotor, more of a...
Dependent. So with the Dynalite caliper, we used to offer them where we would do spacers individually, depending on what your rotor was. So you could have a Dynalite set up for a 3/8 drag rotor, an 810 street rotor, a 1.1 classic rotor, or an 1.25" for some of your circle track dirt application guys. And that was all dependent on the body spacer that was used. What Wilwood's done in the past about 4 or 5 years is actually changed over to a thicker forged flange. So now there's no more body spacers that we use on those calipers. It's just forged body to forged body now, which gives you a stiffer, stronger structure. And again, uses all from the same starting forging that we're working with. If you look over to the left, this is going to be kind of the recycling. So being a manufacturer in California, one of the things that you have to stick up to is standards that California loves to impose through the EPA. And part of that is being able to deal and properly take care of all of our waste. And with this right here, all the chips and everything that Wilwood produces, from whether it's our brackets, our rotors, our calipers, again, we go through about 20 to 30 tons of aluminum shavings every month. And that is all gone back through straight to this pelletizer, which cleans the shavings of all the oils, packs it back down, and gets it right back out the door to the foundry. So that way the calipers can be dropped back in and make more for us.
Oh, so you do your own forging here?
At this facility here, there's a few things we don't do. We don't do our forgings in this facility, our casting, or the pads and fluid in this house.
Okay.
We have other facilities that do that for us.
Right. Hey.
So for example, this right here would be one of the raw rotor casting that comes from our facilities. And then we will go and turn that down, and we'll be able to make either our drilled and slotted, slotted only, or a plain-faced rotor option.
Well, I'm noticing there's some with a blade style, strut in the middle that's directional, but these seem to have a like holes that the air is going to pass through. What's the advantage of that?
Yeah, so back in the day, drilled holes used to have more of a benefit with rotors. And that was because your pads actually had other materials like asbestos in them that would off-gas when they would get hot. And what this gassing of the pad would do is it would push the pad off of your rotor. And with this, you'd lose braking. So back in the day of the 70s and 80s, the answer was, let's drill holes in my rotor so that way the gases can escape and I always have brake. Okay. Nowadays, we don't have that issue with degassing of pads and losing brake because of that. So the drilled and slotted, the drilled holes is truly just going to be an aesthetic upgrade nowadays. Okay. The slotting itself, that is going to be the true performance reason for cleaning the leading edge of the pad and providing some extra feel. But otherwise, drilled holes are truly just an aesthetic upgrade nowadays.
Master cylinder lids.
Yeah, we got a bunch of rotors being done. So there's some of our 16-inch rotors, the ones that we were just getting out in R&D.
Right.
That's going to be the raw casting right there for that guy being done.
Good.
So one of the things that Wilwood also does is, again, we do the brackets in-house for all of our different systems that we work with. So this is going to be a finished bracket that we're working with. And to start, it's going to be from a single block of billet.
Wow.
So you can go and see how much material is just hogged away to be able to get to that finish point. Wow. But again, this one billet is able to do how many different part numbers through Wilwood.
Right.
So that's one of those things that Wilwood specializes in, and again, we will go and be able to make those brackets for other manufacturers out there, because that's what our specialty is.
Okay.
So here are some hat forgings. So again, another thing that you would think may be a billet is going to be a forged piece.
Okay.
So for example, this hat assembly, I can tell this is probably going to be about a 8-on-7 bolt. We're able to get probably about 70 different part numbers out of this one forged piece here.
Oh, okay, wow.
And that will come down to give you a finished machine piece. This is a larger hat. This is actually a different forging, as you can obviously tell. But again, this is going to be a finished piece compared to the raw piece that we get in.
With the multiple bolt pattern too, huh?
Yeah, this is probably going to be a 5-on-4.5 or
5-on-5.
You're correct, probably a 5-on-5 and a 5-on-4 3/4 pattern for this one right here. This looks like a very popular hat that we use for a lot of our Pro Touring and front style systems that we. So again, this is going to be one of our 2-inch drop Mustang 2 Pro spindles right here that we do.
Yeah, that seems to be a very popular front end for a lot of the, you know, everything else.
Incredibly popular. But how many people did you know that owned a Mustang 2 back in the day?
Yeah, because they really, nobody really kept them, and it seemed to be even with, you know, back in the 80s when they started trying to lighten up drag cars.
Yep.
Mustang 2 stuff was it.
Yep. So this is going to be one of the hub assemblies. So again, like you're seeing with our spindles that we do, obviously you need a hub to be able to bolt onto those. So full system from top to bottom that we're going to be offering. This is going to be the net forged piece that we work with. And you come down to a final finished machine hub at that point. So with this one hub, we're able to get, again, about 150 different part numbers out of it, based off of different mount flanges, different offsets, bearing diameters. As we'll start off with a just regular billet if we're doing R&D machines. But if we're doing some lower production runs or volumes, you know, we'll get the billet extrusion in the shape of the caliper.
Yeah.
We'll lop off the individual hats that you need, and then we can machine from that point your piston bores, your mount flanges, and all.
No, that's, you know, I guess you can get anything you want.
I mean, as long as if it's hot enough and enough pressure that you can kind of get what you want.
Yeah, that's very good.
So there's going to be 2 dynos that Wilwood utilizes. We have our link dyno, which is kind of going to be the brains of the operation. That's where you're able to gather all your data sources with your thermocouplers on your pads, your calipers, your rotors. And that's going to be this guy right here.
Yeah.
So this is our link dyno right here, where we're, again, it's actually in the middle of running one of our tests. If you want to stuff that in there to be able to
Can I, I was going to say, can I do a quick?
get as much as you want.
I'd love to.
Hey, Rick. This is going to be our other brake dyno. So this one's entire purpose is to bed in or break in brake pads and rotors.
Really? So
what you'll see in a lot of systems is obviously, well, actually let's even take a step back. You have multiple pad compounds depending on what you're going to be doing. So your standard street car is going to use a different compound pad than a drag race car, which is going to use a different pad than a road race application or an off-road truck. And one of the things that we do is you set up those pads to be used in those vehicles per the temperature range and how the vehicle's going to work. So what makes a pad is all the binders and resins itself that's holding those materials together. So what we're trying to do is heat up the pad and get those materials transferred over to the rotor surface.
I gotta get a bit. This is cool.
Oh, you're good.
Oh shoot. I'm here at Wilwood at the brake dyno. Simulate the brakes. You hear the noise? They're testing the brake systems before they put them on a vehicle. What the heck is going on here?
We'll check out. So here's going to be a Dynalite brake pad, and here's going to be an Aero brake pad. As you can see, there's quite a bit of difference in regards to the overall sizing, but also the volume that the pad has itself. And again, that's not because this caliper has more clamping force or piston area. It's because we need to fill a larger pad to be able to have more life and longevity. So this pad right here, you'll see, will come out of one of our Dynalite 4 pistons, which is a very popular option for drag racing, street driving, 15-inch, 16-inch wheel applications.
Right.
Something that you see on a lot of classic vehicles. And again, we do a ton of these style calipers. Whereas this aero pad is going to be coming in this caliper right here, your 6-piston design. And as you can see, we do small piston. There, we can slide it up here real quick. Yeah, check that out. So as you can see, this is going to be our aero 6-piston caliper. So you'll see a smaller piston, then a larger piston. And the reason being for that is we need to spread out that load across the entire pad. If you had just one equal size piston and an equal size piston, what you'll notice and experience is something that it's called pad taper. And basically the pad will wear more on the entering side of the caliper than it will the exiting side, because it's doing more work on that area. So what we'll do is we'll put a smaller piston on the entering side and a larger piston on the exiting side of that caliper to be able to make sure your pad wear is even, your pistons don't cock, your pistons don't start cocking and side loading in your bores, and everything remains true. Now, another thing to be able to look at, again, like I was saying, is caliper sizing gets bigger, not necessarily for more clamping force, but for more pad volume and longevity in life. So between this Dynalite right here and this Aero, I'm going to ask you a trick question. Which one has more clamping force?
Gosh, that would be the one with the smaller pistons, wouldn't it?
Well, clamping force is going to be your overall piston area or effective size. So for example, this specific Dynalite has 4 pistons, inch 75 bores.
Okay.
That's going to give us a 4.8 inches of clamping force per body half.
Okay.
Whereas this Aero caliper is going to be a 6-piston with an inch and an eighth, and an inch and 5/8 piston. That's going to give you an overall effective clamping force of 4.04 inches. So this caliper, even though it's bigger, takes a larger pad and is more of the performance road course style option, isn't going to have as much clamping force. Wow. Part of the reason why you can get away with that is because you're moving that caliper further out on a rotor, which is providing you more brake torque. So you may go and see a brake system there, an 11-inch rotor on the same vehicle, 11 or 12, will have a 4.8-inch area. But as you move out with more torque to a 13, 14, 15-inch rotor, you don't need all that clamping force. You can bring it down some. Over at the other building, it gets put on the trucks right outside the doors, and that comes over to our building too. This is going to be where all the assembly, powder coat, laser engrave, anodize, shipping, and all that is done before it gets out to the end user at the end of the day, or our distributors to be able to ship from that point. Okay. So if you want to head in real quick, let's go check it out. All product getting ready to leave the door today from Wilwood. And we'll be able to get to this in a point, but again, this is all finished goods here. What's up, man?
Good, buddy.
How you doing? And everything will get fixtured up on its tooling. And then it'll come over into our e-coat bath. So here's a bunch of rotors coming out. These are going to be our new Aero DM rotors for like your 17-inch wheel truck packages. And then these are going to be those 16-inch rotors next to it for your 20-inch wheel truck package towing applications. So everything will go through multiple stages of each of the baths that it gets done in. The rotors will come out in the black e-coat, and then it'll head over into the ovens to be able to cook that e-coat on and finish that process.
Now, does that coating, is it just cosmetic, or is there an advantage to lower temperatures, or?
So the black e-coat on the rotors That is a purely cosmetic upgrade. It's basically a rust prevention.
Okay.
So if you look at these rotors right here, we go and we'll do both the front faces of the hats themselves where your wheel mount surfaces go to, but we also do the actual disc face where the pad contacts. So like we were talking about earlier at the dynos, when you bed in or break in your brake pads, those pads will come in contact with that E-coat and will burn off or wear the E-coat in all the locations where the pad touches. But then inside your vanes, inside the slots, the holes, and these other surfaces, those will remain with the black coating on them, and that acts as a natural rust prevention. Yeah, so these are all aero calipers and the D52s and D154s. So that floating caliper, that bolt-on replacement that we were looking at the other building, that was the inboard half. This is actually the outboard half for that exact body that we were looking at. On the parts themselves or what it's going to be going for. Well, hey Russ, now that you've checked out the building and everything like that, you've seen how Wilwood starts with bringing a vehicle in, raw goods, machining, coatings, and then finally going and getting the product out the door. Well, yeah, I mean, that's pretty much top to bottom on Wilwood disc brakes right there.
I'm really impressed with the whole production process. I mean, it's still an American company here. Mm-hmm. You guys are successful. You're working, you know, people, your people seem to be happy. Your product must be incredible. I've used it myself. I've never had a problem in the world with it. You know, it's just one more thing that says that, you know, what we do here is just better than everybody else.
Exactly. We've been around for 45 plus years going and doing this, and I don't see us slowing down and stopping, you know. So,
yeah. Well, thank you very much, man.
Hey, no worries. Glad to have you guys here. And by the way, before you head out, here's your order for parts. So appreciate you guys stopping by, you know. Get us to come by for some of the smallest things we offer, you know. So.
Perfect, man. Thank you.